Hello, I'm Chris Murphy, and in this video, you're going to learn how to predict the products for reactions with carboxylic acid and anhydrides. To predict the products of reaction with carboxylic acid and anhydrides, you want to find the same key players that are present in a lot of organic chemistry reactions. You're going to want to find a nucleophile, an electrophile, and then a leaving group. When it comes to anhydrides specifically, they're very reactive, and that's going to come down to the leaving group. They're going to be used to synthesize other carboxylic acid derivatives. Just a generic reaction showing how this would work has our anhydride with electrophilic carbonyl carbons. Those are going to be attacked by some nucleophile, and then we're going to be kicking out a carboxylate group as a leaving group. And notice that the carboxylate has resonance, and that stabilizes it, which is why it makes a good leaving group, and the anhydride is so reactive. So a specific reaction that can use anhydrides is to make esters. And we're going to make those from an alcohol, which is going to act as the nucleophile. To see what that looks like, here's an anhydride with its electrophilic carbonyl carbon. There's an alcohol, which is going to be our nucleophile, and then it's going to replace the leaving group, which is our carboxylate. Overall, we're going to end up with an OR group in place of that carboxylate, and that's our ester. And then we also get a carboxylic acid as a side product. Another way in which this specific reaction is used is to take acetic anhydride and react it with an alcohol which protects the alcohol functional group by converting it into an ester. That way other reagents can react with the molecule in other areas other than the alcohol functional group. And then afterwards, the ester can be turned back into an alcohol. Now it's time to apply this concept to a question. Before you predict the product of this reaction, start with what functional groups are provided. On the left, we have an alcohol functional group as well as an aldehyde functional group. Since it has both an aldehyde and an alcohol, this is called an aldol. And it looks like this aldol is going to react with acetic anhydride. And just like so many organic chemistry reactions, you're going to want to find nucleophiles, electrophiles, and then any leaving groups if there's any present. So if you take a look at the aldol, there's an alcohol functional group you've seen as a nucleophile. The acetic anhydride has that electrophilic carbonyl carbon, and it could be either one. And there's also the carboxylate, which makes a good leaving group. So there's an alcohol functional group and an anhydride, and together they make an ester. So really all you need to do is replace the hydrogen on the alcohol with a carbonyl carbon from the anhydride. And there's also that carboxylic acid as our byproduct. So overall, this reaction is really just a nucleophilic acyl substitution reaction. There's a nucleophile attacking a carbonyl carbon, and it's replacing a leaving group. And with anhydrides specifically, they're very reactive because of their good leaving groups, which are resonance stabilized.